Today, I'll be explaining the concepts of the critical angle and total internal reflection, both of which are important phenomena in geometrical optics. These concepts occur when light travels between two medium of different densities, such as from water to air. By understanding these principles, we can see how light behaves at the boundary of two materials and why it sometimes refracts or reflects entirely back into the original medium. Now let's explore these concepts further with the help of an image that illustrates how light behaves as it passes from water to air. On the left side, the light ray starts in water, which is the denser medium, and hits the boundary between water and air. This is called the incident ray, and the angle it makes with the normal, the dashed vertical line, is labeled as O1. As the light crosses from water, which has a higher refractive index, to air, which has a lower refractive index, it bends away from the normal. This bending is due to the change in speed as light enters a less dense medium, and the new angle formed is larger than the angle of incidence. As the angle of incidence increases, something interesting happens. There comes a point where the light ray no longer exits into the air, but instead travels parallel to the boundary. This specific angle is known as the critical angle. It's where the refracted ray no longer exits the water but instead travels exactly along the surface, parallel to the boundary between water and air. In the middle section of the image, when the incident angle equals the critical angle, the light ray goes along the surface instead of passing into the air. This indicates that the refracted ray has reached its maximum angle of refraction, which is 90 degrees. Now, if we increase the angle of incidence even further beyond the critical angle, the light no longer refracts into the air at all. Instead, it reflects entirely back into the water. This phenomenon is called total internal reflection. On the right side of the image, you can see that the incident ray hits the boundary at an angle greater than the critical angle. Instead of refracting, the ray reflects back into the water at the same angle. Total internal reflection only occurs when light travels from a denser medium to a less dense medium, and the angle of incidence is larger than the critical angle. It's a key principle in technologies like fiber optics, where the light signals are kept within the cable due to repeated total internal reflections.